Sorry about that. Let me just wipe this up here. Hi there, this is you. You're a business person, and you're in charge of making lots and lots of money. Recently, you got a job on a business development team at Nike by some stroke of luck, and they're trying to make more money off of their products. They already have various endorsement deals from people such as Kobe Bryant, LeBron James, Michael Vick, Roger Federer, and of course, Mr. Bricker. And that's great. They make a lot of money off of these partnerships, but they're trying to broaden their worldwide appeal to make money off of the entire world and to profit off of their purchases. Almost like Nike's plan of world domination, except not really at all. We know a few things about Nike, including the fact that they make the most money off of their clothing and shoe lines, with which together they make about $500 million a year. So why don't we just make more of everything? Isn't that pretty obvious? No, because it's a little bit more complicated than this. We must set some constraints on the number of clothes and shoes that Nike can produce because obviously they can't just churn out as many of these products as they would like to. Manufacturing limits them to 150,000 of clothes but no more than 500,000. They must have 25,000 shoes but no more than 150,000. So these are all great words, but where's the math? How can we transform this into mathematical symbols? Well, it turns out we already do have them. We have greater than or equal to, which will represent at least, and less than or equal to, which will represent no more than. With these, we can start writing equations, or more accurately, inequalities. But first, we must set some variables. We'll use C and S for clothing and shoes because, well, that just kind of makes sense. We're going to take C and set it greater than or equal to 150,000 because it's at least, and less than or equal to 500,000 because it's no more than. Now we're going to do the same with shoes, except with 25,000 and 150,000. Now we're going to put it into simpler forms so that it will be easier to visualize. 150,000 less than or equal to C, less than or equal to 500,000, and yes, we're done, right? No, wait, hey, stop! Okay, we're not done. It's actually more complicated. But don't have a sad face, because we'll do this together. Factors we forgot to include are the cost of manufacturing, the marketing, and employee wages. We're going to start with cost because we know it takes $30 per pair of shoes and $15 per article of clothing in order to spend a $9 million budget in manufacturing. But where's the math again? Here it is. We're going to use $30 per pair of shoes, which is S, and $15 per article of clothing, which is C, and out of a $9 million budget, that gives us 15C plus 30S is less than or equal to $9 million. And now we have another constraint that we can use in our problem. We write it up here with the rest of our constraints so that we can move on to our marketing. Marketing is everything that would be encapsulated in advertising, which everyone would see and say, yes, we're going to buy Nike products. So we know that it takes $2 per article of clothing and $1 per pair of shoes in order to spend a $375,000 marketing budget. It's exactly the same thing as the other constraint. We're going to take 2C plus 1S is less than or equal to the $375,000 budget. Now all we have left is employee wages, and while I write this last constraint up here, let's talk about what employee wages will look like. We're going to have $2 per article of clothing to pay all of our employees and $9 per pair of shoes in order to spend a $1.8 million budget on employee wages. We're going to use the same old tactic that we have been using all of these constraints, and we're going to end up with 2C plus 9S is less than or equal to 1.8 million, which we'll write up here with all the rest of our constraints. Now we have all the math, seemingly, so it must be time to... Wait, no, Jimmy, stop. Okay, no, we're actually not done. We have to ask ourselves, what's the point of all of this? We have all these cool constraints, but how does this relate to Nike World Domination? Well, we're going to have to look at our profits. Nike being the evil corporate company that they are, we're going to charge an average of $55 per article of clothing and $110 per pair of shoes. Unlike our constraints earlier, there is really no limit. We're trying to maximize this within the bounds of our constraints. So it's essentially the same thing, but we're going to call it a function, or if you're feeling fancy like you do all the time, we're going to call it an objective function. Here it is in all its formal functional beauty. The function of C and S is 55C plus 110S. This is going to function as a profits formula, and we're going to put this in terms of our constraints. But how exactly are we going to do this? Very good question. Well, we're going to have to find a common region between all of the constraints so we can define it in terms of the objective function later. So let's graph it. Before we get to the task, let's make all of these inequalities very graph easy. First, we're going to have to take all of our multiple compounded inequalities and separate them. Sorry about that. And we're going to have to transform all of our standard form inequalities into y-intercept form to make them super easy to graph. So this will become s is less than or equal to negative 1/2 c plus 300,000 as demonstrated by the process above. We're going to do the same thing applying to all to make it negative 2c plus 375,000 and negative 2 times c plus 200,000. So now that we have all of our inequalities, it's time to literally graph everything. Consider a challenge accepted because we are about to do all of the heavy lifting. Because we're not crazy people who can graph everything in our heads, we're going to have to draw out a calculator and put this in ourselves. Let me just type it in real quick. All of our inequalities. Boom. And here is our wonderful graph present with all of its lines, and yes, it is a little bit overwhelming, mainly because of all the lines pointing in every which direction, and frankly it's a bit of a mess, but let's sort through this together. If you look at our graph, there's actually not that much unusual about it. In fact, here's our familiar lines. C is greater than or equal to 150,000 and C is less than or equal to 500,000, if we remember that C is X and S is Y. Each tick mark goes by 25,000, and that's clearly manifest when you see that S is greater than or equal to 25,000. This goes for both the X and Y axis. Here's our three lines. S is less than or equal to negative 1/2 C plus 300,000. S is less than or equal to negative 2C plus 375,000. Of course, S is less than or equal to negative 29C plus 200,000. But where do they all meet? Right there. That little triangle is what we've been looking for the whole time, and now we've found it. Now what we're looking for is the endpoints of each of these points of the triangle, and we're also going to realize that each of these other graphs that don't make up part of the triangle are not really going to matter at this point. We're going to go ahead and erase most of those, because all that matters at this point is negative 2C plus 375,000, S is greater than or equal to 25,000, and C is greater than or equal to 150,000. All of these make up this triangle, and we'll find out the intersections of all of these in order to find the endpoints. Because we're going to take a visual approach about this, we're going to call this 1, 2, and 3, so we can find each of the corners separately in their intersections. So we're going to call point A the one on the top left, point B the one on the bottom left, and point C the corner on the right. So let's say that point A is the intersection of 1 and 2, point B is the intersection of 2 and 3, and point C is the intersection of 1 and 3. So now we're going to have to evaluate all of these in terms of the other in order to find their missing values. Since we know that line 2 is at C is greater than or equal to 150,000 and lies on 150,000x, we can know that this point A lies on 150,000x. So let's put that in. Then we're going to have to find the y value for that. We're going to have to define negative 2C plus 375,000 in terms of 150,000 as x. When we evaluate that, we get S is equal to 75,000. Remember, that's y. So 150,000, 75,000. Now on to point B, which is pretty easy considering the fact that there's 25,000 on the y and, yes, 150,000 on the x. That point will be 150,000, 25,000. On to point C, our final point, and we're going to see it's the intersection of 1 and 3, so we're going to have to evaluate negative 2C plus 375,000, this time in terms of S. So we know that it lies on the y of 25,000, so we're going to plug that in. 25,000 is equal to negative 2C plus 375,000, where we're looking for C, which is actually X. When we evaluate that, we're going to get 175,000, so the point will be 175,000, 25,000. So there you have it, America. We have our 3 points that we can use, 3 points to rule them all, or more accurately, to plug into our profit function, because we can't forget this. We still have to plug it into our profit function of 55C plus 110X. By doing this, we will find which values generate the most profit and recommend to Nike which quantities would suit them best in order to earn the most. So just to review, we have point A at 150,000, 75,000, point B at 150,000, 25,000, and point C at 175,000, 25,000. And now we're going to plug those into our objective function, and this looks like it's about dead. Sorry about that. As I was saying, now this function will be plugged in with point A with 55 times 150,000 and 110 times 75,000, and that'll give us 16.5 million per manufacturing cycle. We do the same thing, applying it to both points B and C, and we'll get 11 million and 12.375 million respectively. So now we know point A generates the most profit, but what does that mean for the rest of the numbers? Well, that actually means that 150,000 clothes and 75,000 pairs of shoes will generate you $16.5 million in income. So now we can tell Nike that these are the optimum numbers, and we have thus succeeded in our objective in order to find the most that Nike can produce during one manufacturing cycle within the constraints that they have supplied. Thank you to the following wonderful people: my grandma and grandpa for lending me an old tripod, my mom for patiently waiting as I filmed her snapping her finger, and Bora because, well, it's his birthday. Happy birthday, Bora.